Hello, welcome back to the battery backup uh, installation preparation according to what I know about it. Okay, the idea is you have your load, which will be what will be used for the power, and for the load you need an inverter to transform the 12-volt current from the battery into 120 volt. 12 volt in, 120 volt out. And you're gonna need batteries that goes to the inverter to supply the load. And you also gonna need, in my case, a charger to recharge the battery when the power is back on. When the power go off, the batteries will feed the inverter, and the inverter will send power to the load to make what you decide to do working. Like in my case, it will be the fridge, freezer, water pump, and the sump pump. To get a better idea, let's see. Same thing here, the load, and then we have the inverter, and we have the charger, and we have battery. Well, we have more than one batteries. We have, in my case, I got several. I will explain to you later how I worked the thing. Okay, but you have to decide which size inverter you're gonna need. For the need I have, I'm gonna need a 1500 watt inverter. And for the batteries, well, I'm gonna need 5 batteries. I will explain that later. Okay. And the way to connect that, you cannot, you need to have bus bar to connect all the batteries to the bus bar. Let's say this is the positive bus bar, the negative bus bar, and let's change color here. Okay, so all, well, sorry for the mess, but all the batteries have to be connected to the bus bar, the positive to one bus bar, and the negative to the other bus bar. Well, it's kind of messy. Anyway, you have the ideas. And from there, the power gonna go in the inverter, both of them, and that will supply the load. And when the power come back, then the charger gonna go, well, the charger gonna go to the bus bar to recharge the batteries. Okay, let's make it a little bit simpler. Okay, let's change color. That we have our load here, inverter and charger. We're gonna put only one battery here for the need, and we have our bus bar here, and with the bus bar here for the schematic, there will be the plus and negative bus bar. Okay, there are some safety application safety consideration to protect your system. Okay. First, each battery needs to have a fuse. The strength of the fuse, for what I understand, the fuse is there to protect the wire transporting the electricity to your different instrument. So you need, for each battery, you're gonna need to put a fuse, and also you're gonna also need between the positive, the fuse have to go on the positive bone of the battery, and you're also gonna need an interrupter switch to cut the power, and that will go to the inverter. And for the positive don't need to have a fuse. Only for the negative, I mean, don't need to have a fuse. Does not need to have a switch either. Only for the positive. This is the negative, and this will be the positive. And for the charger gonna also need an interrupter switch between the positive and don't need an interrupter switch to go to the negative. And you have to do that for each of the batteries. And also very important, in the schematic we don't show here, but for all the batteries connecting to the bus bar, we're gonna have to have an extra fuse here to protect the cable, because the cable going from the battery to the bus bar is not the same cable going to the bus bar to the inverter. So we're gonna need another fuse here, will be a stronger fuse. Okay, so that's pretty good for that. And of course the charger gets this power from the grid. There's many variety on how to connect your system. This system right now is going to be the most basic, and of course eventually you're going to be able to add solar in. Then you're going to need what they call I think is a MPPT charge controller that will connect to the bus bars to recharge the batteries. But that's further on during the year. Right now I'm going to the most basic. Okay, now let's talk about the item you're gonna need. Well, I am going to need to assemble my battery backup. Okay, I'm gonna just change the setup. Okay, before I show you the equipment I got, I have to explain to you why I got those particular piece of equipment. You're gonna have to figure out your own need. For that, you're gonna need one of them instrument, what are called a kilowatt or a power consumption meter. This one is by the brand name Kilowatt. This is been on the market for a very long time, very good. This one I recently got it because the screen is bigger, the screen light up as the first one. It always remain dark, and it's kind of hard for my older eyes to look at the result. So with that, you're going to be able to measure the total consumption for per day. You're going to be able to have an average per hour and have a peak consumption. Okay, so for my need, for what I registered, I will need to have, according to the instrument, 5,784 watt per day. And on average, the consumption is 240 watt per hour. And there was a peak consumption of 1538 watt. That was for the peak, probably when the freezer and the fridge or the water pump, they probably started at the same time, so there was a peak consumption. But the average was 241. So per day, 5,784 watt per day. That's what my inverter I have to come out with. But the best inverter, they are efficient in about 90% of the power from the battery, and the conversion to 120 volt, that's about 90%. So if I divide that amount by 90%, I will need 6,400 watt per day to be able to get the 5,784 watt required for my appliance. And the battery I use are 12 volt 100 amp, and they are supposed to give 1280 watt per day of power before they need to be recharged. So if for my need I got 5 of them, what are they, which give me, let me see, 6,400 watt per day. Oh, sorry, my calculation was wrong here. So what I'm going to need, that 5,784 divided by 90% give me 6,426. And the battery will give me 6,400. So I'm a little short. So technically, my battery backup will not need a whole 24 hours. However, if there is a power outage, I will not take a long shower, or I will not do laundry, and I will not wash big batch of dishes. I will go in economic mode, so most likely I will need less than that amount of power for the whole day, since I'm going to be in economic mode. Okay, so let's see the equipment now. Bon, je will show you the equipment I acquired. Note that I'm not sponsored by any salesperson or sales company to promote any of those products. I pay that with my own money. According to the researches I did, based on what people who know a lot more than me showed me on the YouTube, and those are the equipment I think are the best for my project. But you will have to figure out your own need. Okay, first thing first will be the battery. I decided to go with the lithium battery. This is a 12 volt 100 ampere amp batteries, supposed to give 1280 watt per day of usable power. Why did I choose lifetime? I choose lifetime because in many YouTube video, people who know a lot more than me, they studied these batteries, they even took them apart, and all of them were very impressed about on the building quality of those batteries. Also, I did some research, and depending of the time of the year you buy the battery, let's say I bought them in November, December, and lead time seems to be doing very aggressive marketing, cutting the price and offering great deals. So from November, December, those batteries normally we are in 2024 on Amazon. Those batteries are nearly $400 Canadian. And during November, they make great deals, like 25% off, plus they give you a coupon of $40 to $50 coupons. And so you can get those batteries for under $300. As the other batteries on Amazon, they all range from $360 to $500. So lead time seems to be a good choice. So I got 5 of them. It's still a big investment. And when you buy battery, like I said, 12 volt, 100 amp, I could have get the 24 volt or 48 volt batteries, but I did a calculation. Let's say for a 48 volt battery, 100 amp, that will be the equivalent of 4 of those batteries. And I look at the price for 4 of those. If I was to buy 4 of those batteries, that still will be cheaper than buying a 48 volt battery on the website. Maybe if you are limited in space, you could get for the bigger battery, the 48 volt. But me here, space is not a problem, so it's more economical for me to go with 12 volt 100 amp. And if one of the battery go bad during the years to come, will be less painful to change one battery of 12 volt instead of changing a 48 volt battery. And when you buy this sort of battery, you have to pay attention because they are sold. There are 2 kinds of them. They are the group 24 and the group 31. From what I understood, the group 24 are smaller batteries, and the 31 are bigger batteries with more energy density, not energy density, but bigger storage for energy. The best equivalent, I will have to say, let's say for a double A battery and battery type D, I think, so type D or type C. Anyway, the group 24 will be the equivalent of a double A battery, and the group 31 will be the equivalent of the bigger battery. Same voltage, but the bigger battery have more hump and more power in reserve than the smaller battery. So be careful if you buy those sort of battery. Look for a group 31. They have more energy in reserve than the smaller battery. Okay. After that comes the inverter. I got the Giandel or Gandel inverter. I got the 1500 watt. To make a long story short, like I showed in the peak use of my power consumption, that was 1500 watt. So to make sure everything runs smooth and cool, I decided to go with this inverter, the Gandel, which is very well quoted. The people on the internet who use that, they all are very happy with that. And this one is a pure sine wave. It's very important to have a pure sine wave. If you have a modified sine wave, it's not good. That's what I started with. And when you run something on a modified sine wave, like say for a pump or something like that, you can hear the motor is not happy, or whatever you are running on a modified sine wave is not good. Pure sine wave are more expensive, but they are worth the price. And in that case, this one is a 12 volt, 1500 watt, and they have a peak of 3000 watt for up to 30 seconds, which is good. And you're also gonna need cable. On the website, one good rule of thumb, let's say a 1500 watt is will need cable power supply for up to 150 amp. If you had a 2000 watt, you will need a 200 amp, and so on and so forth. Maybe I should have spent a little more and get the 2000 watt, but the 1500 watt will do fine. Okay. Then comes the rest. Yeah. Let's see what we have here. Huh? Hey. Like I told you, you're gonna need a way to measure your power consumption. I've got these two. The old one, the kilowatt, is very good, and the new one, it's easier to read and have a good. If you disconnect it and reconnect it, the older version you lose everything. The newer version, you keep everything is kept. All the information is kept until you reset it. Okay. You will, like I said, I'm not paid. I paid for everything with my own money. So I'm not sponsored. So you will need cable, electric cable to do your connection. You're gonna need pure copper. Don't get the aluminum the clad aluminum wire, and they are not good. You will need much bigger gauge with copper clad aluminum cable that you will need with pure cable. Get pure cable wire. And in that case, in my case, for my need for my 1500 watt inverter, I will need, I use 4 gauges. Be 4 gauges are good for 150 amp, and I will need 400. I will use the 4 gauge to connect the battery to the bus bar. The batteries are on 100 amp, so a 150 amp cable will be fine. And from the bus bar to the inverter, you're just gonna have to double the 4 gauge. Will give you 300 amp of safety. Okay, so that's good for that. For the cable sheet, you will need lugs and connection when you're gonna do your cable. What is important, when you connect your batteries to the bus bar, all the wiring have to be the same length. Otherwise, there will be a difference in the way the battery are used and recharged. So make sure you always use the same length from one battery to the other, to the connection to the bus bar, in order for your battery to be used evenly. Okay, that came with the inverter. And this is the bus bar. I use, this is a 300 amp bus bar. Do I have a name on that thing? Let me see. Put my glasses. Okay, they are called Tech. Good for 300 amp, 6 lugs. And well, I will put links in the description in the next few days. So if you're interested to look at the same kind of equipment I've chosen, and you decide for yourself if they are good enough for you. From the search I did, they are pretty good. Those are pretty good. And for the budget-minded person. Okay, so that's for that. And of course, you will need some way to connect the cable with the connector and the lugs. So you will need some kind of tool to crimp the lug to the cable. This one is called a shall, S-H-A-L-L, which is one of the affordable one. It's not the best one, it's not the worst one, and the reviews are pretty good on that one. So you have the crimper, and you also have the big cutter to properly cut the wires. It's very important to do a good job. And it's not very expensive. Of course, there is a good one over $200 Canadian. If I were to do that all day long as a business or something like that, I will get the nice one. But this one for my project and the incremental addition I will do over the years, that will be plenty good for me. Okay. And what you're gonna need also for the cable, you're gonna need a way to properly remove the insulator at the end of the cable in order to connect your lugs. And this is a tool to strip the cable. According to what I read, this is a very good tool. This one, we have a name, that one, cable stripper. Well, anyway, like I said, I will put the links in the description. And if you decide to buy from the article on the description, from what I understand, I will get a little commission, but I will not cost you anything more than if you are doing your own search. But that will help me a little bit. So, this cable stripper. And then what do we have here? Okay, so we're gonna need a fuse to go from the bus bar. I don't have it here, that one there. A fuse to go to the bus bar, to the inverter. And this one, since will double the cable to get a 300 amp. The fuse I choose is 250 amp, so will be less than what the cable can take, and more than what the inverter will ever use. For what I understood, the fuses are there to protect the cable, so the cables don't overheat and there's no risk to have fire. So, what do I have here? Okay, that's more lugs and crimping tool. And you're also gonna need switches, to connect. You're gonna need a switch to turn the power off. One between the bus bar and the inverter, and another one between the battery charger and the bus bar. And I have another one here for when I'm gonna go with the solar panel. We're gonna need something to cut the power to the solar panel, from the solar panel to the charge controller. And probably gonna get a better one than that for at that time. Okay, and let me see. Yeah, I'll be right back. I went back to get one of the battery who already have a fuse installed on it. I don't know if you can see it. You can see here. I'm gonna move that away. Like I said at the beginning, it's very important that each battery is fused between the battery and the bus bar. So in that setup here, that's a connector, go for the battery connector, and the fuse is right here. And in my case, I got a 150 amp fuse. The battery is 100 amp. The cable can take up to 150 amp. Maybe I should have got a 125 amp for that fuse. But the funny thing, you have to be careful when you shop, because on Amazon, on the same page, the 150 amp fuse was something like $18, and the one for the 125 amp fuse was something like $53. A big increase. I guess the 125 amp is the one the most used, and the seller for some reason decided to make some money by increasing the price compared to the other value of the fuses. Anyway, I will go with the 150 amp for now, and later on I might decide to put the 125 amp. I will see. So that's pretty much it for the equipment. I just need to install everything and to assemble it and get it ready to work and make some test runs. That should be fun. Okay, thank you.